In section 5.7, we're going to take a look at graphing radical functions. Before we get to the first problem, which is what are the graphs of y equals the square root of x minus 2 and y equals the square root of x plus 1, what I want to do is take a look at the parent function, which is y equals the square root of x. Now, the vertex form that we're going to use for this is y equals a times the square root of x minus h plus k, where x minus h is the radicand and k is outside of the radical. Again, the opposite of h is going to show you your horizontal movement, and the k value is going to show you your vertical movement. Now, with the parent function, as always, the a value is 1, so that means that there's no stretch, compress, or reflect. The h value is 0, and the k value is 0. So we know that the vertex, or what is acting as our starting point, is not going to move any. Then the domain for these, the way that we graph radical functions is that it's going to be a half of a parabola, either opening above the starting point or opening below the starting point. Unless we have a plus or minus a radical, then we'll have a full parabola that opens both above and below that starting point. So on this one, since there's no reflection, the domain is going to be 0 to infinity, and the range would also be 0 to infinity. So if we were to graph it, we're going to pick points that are greater than 0. And if we choose 0, 1, I'll choose 0, 1, and 4. The reason for this is that when I plug those particular numbers into the radicand, you're going to end up getting an integer as a solution. So if we do the square root of 0, we get 0. If we do the square root of 1, we get 1. If we do the square root of 4, we get 2. So again, we know that we're going to get an integer, and we're not going to be dealing with any sort of fractions when we're graphing. So now that you've got that done, let's take a look at what happens when we do translations. So you've got the square root of x minus 2. So again, our a value is 1. There's no stretch, compress, or reflect. The h value is still 0 because it's technically x plus 0 in that radical. And then the k value is negative 2. So this means that the entire graph is going to be moved down by 2 units. The vertex, or the starting point, is going to be 0, negative 2. The domain is still going to be 0 to infinity, but this time the range is going to be negative 2 to infinity. For y equals the square root of x plus 1, the only thing that's going to change with this is from the parent function is that we're going to move everything 1 unit up. So now that we've done that, we need to start getting some extra points to fill in here. Now, again, what I would suggest is that whenever you're trying to deal with a radical function, that you choose values in the radical or for your x value that are going to give you integer values coming out of the radical or out of the square root. So in this case, since we haven't added or subtracted anything to x, then we'll just use 0, 1, and 4. So you can see what we get when we plug in 1 for x and we plug in 4 for x on the first one. We get y equals negative 1 and y equals 0. When we do the same thing on the second function, the square root of x plus 1, we get y equals 2 and y equals 3. So then we go ahead and create some xy charts and fill those in, and then you can graph it, and you can see the translations from the parent function to both the minus 2 and the plus 1. Now in problem number 2, we're going to work inside of the radical, and we're going to change the value of h. So again, I've got the parent function already on the graph, so you can see what that looks like and how the translations are going to act based on the numbers that we've got in our equations. So for y equals the square root of x plus 4, the a value is 1. Again, no stretch, compress, reflect. The h value, though, is going to be negative 4. So we know that we're going to be moving 4 units to the left on this. The k value is 0, so no units up. And then the domain on this is going to be negative 4 to infinity. The range, since there was no k value, is still going to be 0 to infinity. Now on the second one, y equals the square root of x minus 1. The a value is still 1, which means no stretch, compress, or reflect. The h value is now positive 1. So we know that we're going to be moving that parent function 1 unit to the right. K value is still 0, so that means the vertex or the starting point is at 1, 0. The domain then is 1 to infinity, and the range is 0 to infinity. Now, this is where it gets a little bit more complicated in that we want to figure out we want to put in values for x that are going to give us a radicand of 1 and 4. So ask yourself this question. What value of x am I going to substitute that I'm going to add 4 to that is going to give me a result of 1? So 4 minus what equals 1? Well, 4 minus 3. So you would want to put in negative 3 for x. Then what result or what value of x is going to give me 4 for the radical? So what plus 4 equals 4? 0 plus 4 equals 4. So then you know that you're going to be using negative 3 and 0 as your x values. On the second one, y equals the square root of x minus 1, we're going to be looking at, again, x minus what equals 1, and that value is 2. Then x minus 1 equals 4, 5. So we're going to do 2 and 5 for the second equation. When we do that, the results that we get for both equations are going to be 1 and 2. So now we're going to take all of those points that we've just created, put them into XY charts, and then graph them, and you can see the translations whenever we're dealing with a horizontal translation for a radical function. Now in problem 3, we're given an equation in which we've got to make adjustments for a, h, and k. So we've got y equals negative 1/2 square root of x minus 3 plus 1. We know that the a value is negative 1/2, so the negative tells us that there's going to be a reflection, and the 1/2 tells us that there's going to be a compression. The h value is going to be 3, and then the k value is going to be 1. So that we know that we've got a vertex or a starting point of 3, 1. That then tells us the domain is 3 to infinity, and the range is actually going to be negative infinity to 1. Now, the next thing that we've got to do is we've got to figure out some extra points so that we can graph the rest of this. Since this is only going to be a half a parabola, we're only going to use 3 total points, and we've already got our starting point, so it means we only need 2. So again, what you should ask yourself is, what value of x is going to make the radicand 1? What value of x is going to make the radicand 4? So the first value would be 4. X equals 4 would make the radicand 1. So 4 minus 3 is 1. The square root of 1 is 1. Times negative 1/2 is negative 1/2. Plus 1 is 1/2. Then what value of x is going to make the radicand 4? That would be 7. So 7 minus 3 is equal to 4. Square root of 4 is 2. Times negative 1/2 is negative 1. Plus 1 is 0. So now we've got enough information to go ahead and create XY charts, or an XY chart, which we've done here. And you can see that we get a compressed graph that opens downwards rather than opening above the starting point. So for the next problem, we're going to try the same thing, except we're going to do it with a cubed root function. And in this case, we're given y equals 2 cubed root of x plus 1 minus 4. So again, just go ahead and work through all of your information that you want to know. You know that the a value is 2, so that tells us we've got a stretch of 2. The h value is negative 1, the k value is negative 4. So that tells us that the vertex, or that central point, is going to be negative 1, negative 4. The domain for the cube root function is, or for a cube root function is going to be negative infinity to infinity, and the range is also going to be negative infinity to infinity. Basically, all we're doing is we're taking a cubic function and we're going to be turning it on its side. Now, the hard part, we've got to figure out some points to be able to actually find out what the graph is going to look like. So here's what we want to do with this. When we did the square root functions, we said that we wanted to make the radicand into a 0, a 1, and a 4. Now, when we're doing a cubic function, we want to make the radicand into a -8 and a -1, a 0, and then a 1, and then an 8. And again, the reason why we want to do this is because 0, 1, and 8 are all perfect cubes. So what value of x is going to give us -8 inside the radicand? We're going to substitute -9. What value of x is going to give us -1 in the radicand? That would be -2. What value of x is going to give us 1 in the radicand? That would be 0. And then what value of x is going to give us 8 in the radicand? And that would be 7. So when we sub all those in, the resulting y values that we get are going to be -8, -6, -2, and 0. Once you've got that, you can create your XY chart. And then once you got your XY chart, you can go ahead and graph all those points, and you can see that we get this wave type of graph that we would normally associate with a cubic function, but it's also a cube root function as well, just turned on its side. Now, not every equation that you're going to get is going to be as neat and tidy as getting a vertex form of an equation. So in problem number 6, we're looking at how can you rewrite y equals the square root of 9x plus 18 so that you can graph its transformations without having to go into a graphing calculator, basically. So what we're going to do is we're going to look at that original radicand, 9x plus 18, and we're going to say, are there any perfect squares that we can factor out of it? And we can factor out a 9. So if we factor out the 9, that's going to leave us with 9 times x plus 2. Well, we can, just like any other radical equation, we can pull one thing out and leave the other thing in. So we're going to pull out that factor of 9, and we're going to leave the factor x plus 2 inside. So what is the square root of 9? It's 3. So we're left with y equals 3 times the square root of x plus 2. At this point, we have a graph, or we have an equation in the form of y equals a times the square root of x minus h plus k. We know that this is going to be a radical graph, which is a half parabola, opening to the right with a stretch of 3, and it's going to move 2 units to the left because we've got an h value of -2. There's not going to be any vertical movement because our k value is 0.